Hi guys, we are going to look at probability part 2 that has to deal with counting techniques in probability, where we are going to look at combinations and the permutations. What can we say about this particular topic? We normally refer to it as a combinatorial analysis, and we know that in some probabilities of complex events, you might find that these particular techniques might be handy in the counting of these cases, which are proven to have been proven to be difficult and tedious and sometimes laborious, or in fact both. To save labor involved, you find that you normally apply the combinatorial analysis in these particular situations. So that's the importance of this particular topic. And every student or every person who is dealing with probability needs to be well abreast with these particular counting techniques. We talk about axioms of combinatorial analysis, where we have an event or we can say where an event can happen in more than one way, and another event follows and can happen in one or n ways. The number of ways in which both events happen to be in specific order, n1, n2. So you can see that you can have a situation whereby you have some event which can happen in n1 ways, and another event which can take off in n2 ways. The number of ways in which there is both or these two events or both events can happen in a specific order is taken to be n1 followed by n2. So that's the order or the logic behind these axioms of combinatorial analysis. Let's look at an example to illustrate this particular new techniques of counting. Okay, example, let's say you are asked to find the number of ways in which two offices of chairman, for instance, and treasurer can be filled, given there are 2 and 3 candidates respectively. So here it means that for office of chairman, there are 2 competing candidates, and the office of the treasurer, there are 3 candidates who are competing. Okay, so now we want to find out in how many ways in which these 2 officers, chairman and treasurer, can be filled, given this type of situation. So when you are using combinatorial analysis, this is how we go about it. We can actually denote the number of ways in which the combination can, the number of ways in which 2 officers chairman can the offices of chairman can be filled in is n1, which is given here 2, and the number of ways in which the office of the treasurer can be filled in is n2, which is given here 3. So we have n1 is equal to 2, n2 is equal to 3. Hence, n1 followed by n2 is going to be n1 times n2, which is going to be 2 times 3, which is 6 ways. So that's how we analyze this type of situation. Let's look at the factorial notation, which is also an important aspect that we need to look at in this particular situation. The factorial notation. Okay, so for those who are going to be using combinatorial analysis, you cannot run away from this particular notation, factorial notation, which is actually represented as n factorial. This n with an apostrophe more like an exclamation mark. This is pronounced as n factorial. That is, n factorial is given by n multiplied by n minus 1 times n minus 2 times n minus 3 times n minus it continues up to the end. Okay, so that's how it is done. So you keep on reducing the n by 1 as you proceed. Okay, so that's how it is, such that if you have n 3 factorial as given here, then it simply means that you are multiplying 3, the next one reduced by 1, you multiply by 2, then that is multiplied by 1. So until you end up with 1, that's when you end this particular analysis, the factorial notation. Okay, so you have n factorial means that 3 times 2 times 1, which is equal to 6. So that's how you look at n factorial. So we move on to look at the next one, which is permutation. Okay, what do we mean when we say permutation? Permutation is where there are n different arrangements or orderings or pairings or ways of elements taken at a time. Out of them, n elements, and the repetition is permitted or allowed. Okay, so when we talk about a permutation, we denote that one by a number of ways you can find in different literature. You can either be given n PR in this form, showing that this is the permutation arrangement, or it can be given in this form, P and then open bracket n comma R, that is again the same, it means the same, is a permutation arrangement. Or you can be given this, okay, again you find that this is the same, or you can be given this one. So all these mean one and the same thing, they denote the same thing, which is permutation. So now in this particular illustration or elaboration of the formula, the functionality of this permutation is given by n multiplied by n minus 1 multiplied by n minus 2 multiplied by n minus, until you reach this particular n minus r plus 1. Okay, so when you simplify this one, the axioms of these particular mathematical statements, they will simplify to this particular arrangement here. Okay, they simplify to this particular arrangement. That is what is known as the permutation formula. Okay, permutation formula, which tells you the number of different arrangements where repetition is allowed. Where repetition is allowed is a permutation. Okay, it's the number of orderings where permutation, repetition is allowed. So that's what is given there. Okay, for instance, let's look at an example into this effect. Let's say the number of permutation of letters A, B, C taken 2 at a time, okay, is given by, in this particular case, we are going to have, in this particular case, the n is the number of elements or the number of items. So there are 3. So n will be 3. Then how many times at a time taken is 2. So R is 2. So when you look at this type of presentation, we have this in this form, okay, where we have n is equal to 3 and we have R is equal to 2. So that's what we have here. So what we do, we look at this formula or model. We are going to say, according to this formula, it is n factorial divided by n factorial divided by open brackets n minus r close bracket factorial. So that's what we are going to look at in this particular case. So n factorial, which is 3 factorial, divided by open bracket 3 minus 2 everything, then the difference, get the factorial of that, meaning that you simplify to this 3 factorial divided by 1 factorial. Now, as I said, 3 factorial simply means 3 times 2 times 1. So then 1 factorial is always equal to 1. So it will be 6 divided by 1, which is equal to 6. So meaning that these letters A, B, C under permutation can be arranged in 6 ways where repetition is allowed. So what we mean by repetition is allowed? Let's look at this. These letters A, B, C can be arranged taken 2 at a time. So it can be A, B, or B, A. Okay, or we can have A, C, and C, A. We can have B, C, and C, B. So now what is this we're calling the repetition? When you look at A, B, these are the same elements which are just transposed again with B, A. So meaning that this is a repetition of the same kind of arrangement in terms of if you are talking about maybe the factors, the A times B, B times A. Okay, so you are repeating the same items. So repetition is done here. Again here you have AC repeated as CA. Here you have BC repeated as CB. So this giving you taken 2 at a time. The orderings can be 6. Repetition is allowed. Okay, so that's why you have this one being called a permutation. So the number of permutation of n objects consisting of groups of which n1 are like, n2 are like, is given by n factorial divided by n factorial, n1 factorial times n2 factorial. Okay, where n is equal to n1 plus n2 plus up to the infinity. So that's how it is. Okay, so where you have like items, so we're going to see in the next examples how this particular formula is used. N factorial divided by n factorial, n1 factorial, n2 factorial. If there are 3, there will be another one, n3 factorial. Okay, so let's look at an example that will demonstrate this one. For instance, find the number of ways in which the letters in the word can be arranged. Okay, the words can be arranged. So we have statistics and the committee. The letters in the words can be arranged. So we want to see for statistics. So what are the identical letters? We have S. How many S do we have? We have 1, 2, 3. Okay, so it means that if we take S to be N1, then N1 is equal to 3. Let's look at T. How many T's do we have? We have 1, 2, 3. Again, if T is represented by N2, then N2 is equal to 3 as well. Let's take at A. How many letters of A do we have? We have only 1. So N3 will be 1. Let's look at I. How many I do we have? We have 2. 1 here and another one here. So N4 will be 2. We have dealt with S. What of C? There is only 1. So N5 will be 1. Okay? So that's what we have there. So let's look at the workings. Okay? Okay. So what are we saying? We have 3S, 3 T's, 1 C, 2 I's, and 1 1A. So how many letters are we talking about in statistics? There are 10. So n factorial will be 10 factorial. Then the separate ones which are labeled N1, N2, N3 in terms of category. In category of S, there are 3. So 3 factorial. In category of T, there are 3. So 3 factorial. So you multiply those separate categories factorials. So you are going to end up with 10 factorial is the same as 10 times 9 times 8 times 7. Here times 7. Okay, times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is 10 factorial. Then you have 3 factorial. The first 3 factorial is 3 times 1, 2 times 1. The next 3 factorial is 3 times 2 times 1. Then 1 factorial is simply 1. 2 factorial is 2 times 1. 1 factorial is still 1. So that's what you have at the bottom here. Okay? That's what you have at the bottom here. So what do you get after all that? What do you get after all that? What you are going to get is the number. Let me just expand it a bit. Okay. Let me see. Put them in order. Okay. Right. Okay, it's something like that. So meaning that you are going this numerator figures, they will be coming to a figure of 3,628,800. And then the bottom one, the denominator, when you multiply all this to be 72. If you divide 72 into the numerator, you're going to have 50,400. Okay, 50,400. This is due to the fact that, as I've said, there are 3 S, 3 T's, 1 A, 2 I's, 1 C. That's what is resulting from this. Okay, that's what we have. So the next one we look at is that which is involving the word committee. In the like manner, we analyze how many C's do we have? We have 1 C, so N1 is 1. How many O do we have? We have 1 O, so N2 is 1. How many M do we have? We have 2, so N3 is 2. How many I do we have? We have 1, so N4 is 1. How many T's do we have? We have 2, so N5 is 2. How many E's do we have? We have 2, that N6 is 2. So how many total numbers of letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So N is 9. So we come here. N is 9. So it will be 9 factorial on top, which will be 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 2 times 1. Then you look at, as I've said, 1 times 1 times 2 times 1, because there is a committee, there is 1 C, there is 1 O, there are 2 M's, that is committee, so N3 is 2 factorial, so 2 times 1. Okay, then there is 1 I, so times 1. Then there is 2 T's, that is 2 times 1. Then 2 E's, that's 2 times 1. So when you evaluate this, it will end up giving you 362,880 on top. And then when you multiply the bottom one, it will give you 8. Finally, when you resolve this one, you are going to end up having a figure of, let me just put this one on top here. Okay, let me leave it at it. You're going to have a figure of 45,360. So that's the answer for this other committee. A number of ways in which these letters can be arranged. So that's how we solve that one. Then we look at the next one, which is circular arrangement. Okay, circular arrangements. Now you need to know a number of things about circular arrangement. One, I've said that when elements are arranged in a circle, there are 2 possible factors to consider. One, Or A, find out if all arrangements are considered different. Or B, whether the arrangements achieved by rotation are considered the same. So that's what you should determine. So let's look at what happens in this particular case. We have all arrangements considered different. When all arrangements are considered different, this is how you now find the number of arrangements that are involved. You just look at the permutation, because all arrangements are considered different. So it means that the repetition is allowed. So you carry out you determine the permutation in this manner, n factorial. Okay. So then when arrangements achieved by rotation considered the same, arrangement achieved by rotation are considered the same, then what to do is you are going to find n minus 1 factorial. That's all you need to do. So these two formulas, when you are talking about circular arrangement, this is what you need to consider. Find out if there are two conditions, all arrangements considered different, then this is the formula you do. If arrangements achieved by rotation are considered the same, then this is the formula you use in calculating the permutation. Okay, fine. The other one is what we have. Maybe look at the other one. We have just looked at permutation. So we have just looked at permutation. Let's look at combinations. How do we deal with combinations? Okay. Now for combination, this can be described as a situation where n different elements or arrangements or ordering are taken R at a time of n elements, but in this case repetition is allowed. Is not allowed. Repetition is not allowed. For combination, repetition is not allowed. So where n different elements or arrangements or order taken are at a time out of n elements and the repetition is not allowed, then that is a permutation. Not allowed, then that is a permutation. So what we do is we look at the arrangements. How are the arrangements in this particular case? So first of all, the formula or the combinations denoted by this particular formula or the symbols, like permutation, we have n, then capital letter C, then R. So that's how you put it. Capital letter C, then open bracket n comma R, or capital letter C, n R in this manner, or C then R n R, like made in this arrangement. So these are the different ways in which the same denotation of combination can be done in calculating or determining the combination, where a number of orderings or pairings or arrangements are taken n at a time, and the repetition is not allowed. Repetition is not allowed. So what do? We find that in the formula is almost the same as the permutation, but what we notice, there is this R factorial down there. R factorial which is put down there. So R factorial which is put down there, meaning you are looking at more like a permutation divided by R factorial, which is the same as what you are seeing here. So this R factorial, which is taken to be the same as 1 over R factorial, is known as the correction factor. This correction factor is the one which is responsible for removing the repetitions, or the repetitions, yes, where repetition is not allowed. That's because that's the condition under combination. So the correction factor, which is 1 over R factorial, is the one which removes the repetition in a permutation. Then it turns it to be a combination. So that's why you find it's almost the same as the formula for permutation, but there is down here what is given as R factorial, as to actually correct the repetition or eliminate the repetition. Okay. So then we move on to look at combination of letters A, B, C, D taken two at a time. So we have AB, we have AC, we have AD, and then we have BC, BD, and then we have CD. So you can see in these letters, unlike where we had the permutation would have seen after AB would have seen BA, after AC would have seen CA, after AD would have seen DA, meaning that the same elements are repeated. So, but this is not the case under combination because repetition is not allowed. So, because of that, you end up having the model represented like this, where there is a correction factor. Okay, so when you look at this, how many arrangements are these? The 1, 2, 3, 4, 5, 6. If you use the formula for combination, where it has a correction factor, you end up resolving in this way. So you have n is 4, r is 2. In the formula, there will be n factorial divided by open bracket n minus r factorial, then r factorial. So that is the 4 factorial you are seeing there, then 4 minus 2 factorial, then 2 factorial. So basically you are going to have 4 factorial divided by 2 factorial times 2 factorial. So when you look at that one, you are going to have actually 4 times 3 times 2 times 1, then 2 times 1, which is a 2 factorial, then again 2 times 1, which is a 2 factorial. So if you cross out this and that, you are going to have 4 times 3 divided by 2 times 1. 4 times 3 is 12, 2 times 1 is 2, 12 divided by 2 will be 6. So that agrees with what we have given here, AB 1, AC 2, AD 3, BC 4, BD 5, CD 6. So these are the arrangements under combination. Okay, so I've already mentioned about this 1 over R factor as a correction factor, which cancels the repetition in the permutation to arrive at a combination. Okay, then we also have that's all we have. That's all we have. So thank you for listening. Please remember to subscribe to my channel and like my videos. Thank you for listening. Until next, goodbye.